So in this first example, we can see we have to find out what is the value of wy, which is basically asking us how far is it from w to y. That's what this notation would it be asking us. How far is it from w to y? And you can see it's represented in the picture as 2n plus 7. So it sounds to me like we need to figure out the value of n first. Now what we have going on in this picture is we have a triangle XZY, and then we have two smaller triangles. And we notice that the distance from Z to X is the same as the distance from Z to Y. And what we learned, so another way to say that, let me back up. Another way to say that is that Z is equidistant from the endpoints of segment XY. It's the same distance from X as it is from Y. And what we learned is that when a point like Z is equidistant from the endpoints of this segment XY, then it must be on the perpendicular bisector of that segment. Now every segment only has one perpendicular bisector. It's not like there's multiple perpendicular bisectors of this segment. There's only going to be one. And remember, the perpendicular bisector is both perpendicular to and bisecting the segment. It's perpendicular, making a 90-degree angle, and it's going to go through its midpoint. We can see segment ZW here is perpendicular to segment XY. And so what that tells us is that segment ZW must be the perpendicular bisector of segment XY, because Z is on that perpendicular bisector due to it being equidistant from the endpoints. And segment ZW is perpendicular, so it must also be bisecting segment XY. Long story short, that means that the distance from X to W is going to be the same as the distance from W to Y. Let me write that out. The distance from XW is going to be equal to the distance from W to Y. Now the distance from X to W is 5n minus 2. The distance from W to Y is 2n plus 7. So now what we do is we substitute 5n minus 2 in for the XW, and 2n plus 7, we substitute that in for WY, and now we have an algebraic equation we should be able to solve. I'm going to subtract 2n from both sides, and that's going to give me 3n minus 2 equals 7. Then I'm going to add 2 to both sides, and I'm going to have 3n equals 9. Then I'm going to divide both sides by 3, and I get a value of n equals 3. And since wy is equal to 2n plus 7 in the picture, we can say that it's equal to 2 times 3 plus 7, which is 6 plus 7, or 13. In this second example, we have a little bit more complicated looking picture here, and at the end of the day we have to figure out how far is it from O to L. So let's kind of look at what's going on here. What are the clues that they're giving us in this picture that could maybe lead us down a path that ends with us knowing how far it is from O to L? Well, I'm going to concentrate on triangle JKL right here, this big triangle, and I'm going to notice that K is equidistant from J and L. It's 17 units from K to J, and it's 17 units from K to L. I also notice that Kn is perpendicular to JL. So that tells me that Kn must be the perpendicular bisector of segment JL. Because K is on the perpendicular bisector, Kn is perpendicular to JL, so n must be the midpoint of segment JL. So why is that important? Well, that tells me that the distance from N to L is 14. Let me go ahead and put that into my picture. The distance from N to L, I'm going to write it up here, NL is 14. So from here to here is 14. Now point O, I kind of covered up my O, so let me put an O right back in there for that point there. So now that I know that this is 14, now I can look at this smaller triangle right here. And I notice that M is equidistant from N as it is from L. So actually, I think this might be helpful. I'm going to redraw that smaller triangle down here, just so we don't have a lot of other things kind of distracting us in this picture. We got 9, there's point M, here's a right angle. I know that it's 14 units from there to there. So now if we look at M, it's equidistant from the endpoints of segment NL, so it must be on that segment's perpendicular bisector. MO is perpendicular to that segment, so O must be the midpoint of segment NL. And if the whole thing is 14 units long, that would tell me that each of these sides must be 7. So OL would be equal to 7. Now in example 3 we have a picture, and we have some information up here about this picture. And it says if h to I is 7 units, and I to j is 7 units, and the measure of angle HGI is 25, what's the measure of angle IGJ? So the first thing we want to do on a picture like this is anytime we are given some information about the picture in writing, we always want to transfer that information onto the picture itself. So I'm going to put a 7 for the length of segment HI. I'm going to put a 7 for the length of segment IJ. I'm going to put that 25 degrees, I'm going to put that right here for the measure of angle HGI. And then I'm going to tell myself this is what I'm trying to find right here. So why are these clues here? What are these clues trying to tell us? Well, I notice that IH, segment IH, is perpendicular to segment GH. So that segment is representing the distance from I over here to this ray. And the same thing's happening with segment IJ. It's representing the distance from I to GJ. And I notice that those two distances are equal. And so what we learned in the last video we did is that if I is equidistant from the two sides of angle HGJ, which it is, then it must be on that angle's bisector. So angle HGJ is getting bisected by this ray GI. Now up here we have 25 degrees for one part of that angle. That means this part down here must also be 25 degrees. Finally, we have another example here. It's actually the same picture that we used in the last example, but with just some different information. So let's go through and put this information from the picture onto, or from the wording onto the picture. It says that the measure of angle HGJ is 57 degrees. So I'm going to mark one big arc here. I'm going to put an arrow there that says that that is 57 degrees. And then it says that the measure of angle IGJ is 28.5 degrees. So that is 28.5 degrees. It says that HI is 12.2, and we want to know how far is it from I to J. So what do we got going on? What are these clues trying to tell us in this picture? Well, why would they give us these two angles? The entire angle HGJ is 57, and then this portion of it is 28.5. Well, let's think real quick that if the entire thing is 57 and this part's 28.5, what's this part right here? Let's just do some quick math. We know that the measure of angle IGJ plus the measure of angle HGI would be equal to the measure of angle HGJ. We know that what we're saying here is that these two angles should add up to this one big angle. And now if we substitute in some values that we know, for instance, we know that the measure of angle HGJ is 57 degrees. We know that the measure of angle IGJ is 28.5 degrees. Then if we look at this and just subtract the 28.5 from both sides, then that would tell us that the measure of angle HGI is also 28.5 degrees. So this angle right here is also 28.5 degrees, which means that this ray, GI, is bisecting angle HGJ. The two parts of it are congruent. This is bisecting it. And we learned that any point that's on the angle bisector of an angle will be equidistant from the two sides. So if from I to H is 12.2, then that would mean that from I to J is also 12.2.